Hi everyone, this is Andrew Hoffman. For those of you who haven't seen my content before, I'm a software engineer, a security researcher, and a technical author based out of the Pacific Northwest. Today's video is special. Recently, I found my copy of Pokémon Yellow Special Pikachu Edition for the Gameboy Color. I decided to try to play it again, but this time I wanted to beat it with only a Pikachu. I was successful until I got to the first gym. See, the first gym is a rock-type Pokémon gym, and Pikachu is an electric-type Pokémon. That means that the rock-type Pokémon not only deal more damage to him, but many of Pikachu's most powerful abilities will do no damage to a rock-type Pokémon. Noticing this, I thought to myself, what should I do in this situation? I want to complete the entire game using only Pikachu. And then it came to me, I should use my skills to reverse engineer my physical Pokémon Yellow cartridge, learn how not only the Pokémon Yellow game is coded, but also how the Game Boy Color makes use of Pokémon cartridges and Game Boy cartridges, even including non-Pokémon games. And then I should write a hack that allows me to implement a Mega Pikachu in my game, a special variation of Pikachu that's so powerful it's even capable of taking on rock-type Pokémon. This is the story of how I chose to reverse engineer and hack my Pokémon Yellow game for the purpose of defeating Brock, the rock-type gym leader. Let's get into it. So first things first, as you can see, my copy of Pokémon Yellow is a little bit dirty. That's because it's an original from the 1990s, and as a result of that, it's probably been sitting in a box for over 20 years. So 2 decades in a box with a whole bunch of other stuff rubbing up against it, sun, snow, moving from place to place, it's gotten dirty. So I mixed a little bit of degreaser with some water, tried to do some circular motion with a lot of pressure without damaging the case, and my goal was, although this won't get perfect, to try to clean up the cartridge as much as possible. That way I don't have to worry about any conductive grime causing any interference when I start playing around with this as I take the cartridge apart and start looking at the electronics. So there it goes, quite a bit cleaner. So next up, now that I've cleaned up this cartridge, I grabbed some tools just in case I have to do some cleaning when I get to the inside, but most importantly, I actually need to get to the inside before I can see what Pokémon Yellow is actually made of. So one thing I found when I tried to take this Game Boy cartridge apart is there's actually a security mechanism built into every Game Boy cartridge. As you can see right here, there's a little screw, but the screw doesn't match any screwdriver that I was aware of, and that's because, well, it's a DRM screw. It's actually designed to break the Game Boy game if you try to force it open. Furthermore, it's designed in a way that it doesn't match up very nicely with any production screw or screwdriver, so it's pretty hard to get inside of these games. That's okay, I wasn't gonna let that stop me. There's some ways around this. But in general, I learned that it was going to be a little bit more difficult than I expected just to get the internals of this Game Boy game exposed. So as you can see right here, what I've done is I've actually grabbed a tool that is used for working with glasses. It's also a tool that seems to be pretty useful when you want to reset electronics. They often want that very small pin. This is just, you could think of it as a very thin metal aluminum rod with a very strong grip on it, and because of that, even though I didn't have a screwdriver that matched this DRM screw that was intended to protect me from getting inside of the Game Boy cartridge, I was able to use this little metal device and I was able to push it around, and you'll see I keep cleaning up the screw. And the reason why is because over time a little bit of rust accumulated on that screw. So as I'm trying to push it, as I'm trying to get through it, I'm noticing that occasionally it slips. Now I grab right here some other tools. First thing I do is I grab a magnifying glass just to make sure that rust is out. And then, since I had got the screw slightly out, I figured I would go to the needle nose plier, and there we go. We got the DRM screw out. I got the DRM screw out. And if you look at it in my hand, you'll see just how strange this screw really is. It's a polygon shape, whereas traditional flathead is a straight line and the Phillips head is a cross. Yeah, this is a polygon, very, very unique. And I actually learned later on that you can buy a DRM screwdriver aftermarket from China on Amazon. I did not know that at the time. Now I used a knife in order to open up the cartridge the remainder of the way, just because the plastic was a little bit stuck. And I finally got to the internals of this Game Boy game. This is what a Pokemon game looks like on the inside for those of you who have only seen the outside of a Pokemon game. Now, I figured the next logical step would be to go through every component on the chip inside of the Game Boy cartridge and use hardware search databases to try to figure out what they do and what their purpose is. Turns out this is pretty easy because the Game Boy cartridge has been around for quite a while, and there's a number of modders who have taken the time to really dig into the internals of these cartridges and document them online. So for the sake of this video, I figured that I would diagram out what I learned from my research. Now, as you can see, the Game Boy cartridge has a number of major components. In fact, I would say visible on the board, there are 5 major components that you have to know about if you want to mod a Game Boy game. And these 5 components you'll see I'm drawing lines from, because I figured I would not only draw a diagram, but I would also do my best to document them. So let's start at the top right. Obviously, this is the battery. It's a 3-volt battery, and its purpose is actually to persist the save files on SRAM when the Game Boy is not turned on. So the way in which save files are stored, they're stored in static random access memory, which requires a little bit of power in order to persist, and when this battery dies, you'll lose your save file. So keep that in mind. If you've ever lost a Game Boy save file before, you might just need a new battery. Now below that we have the ROM, which stores the game data, and on the top left we have a chip called MM134. This is a supervisory circuit that's responsible for controlling the battery and the SRAM. Below that we have a slightly bigger chip, and this is the MBC, Memory Bank Controller. This is responsible for switching between memory banks in the ROM. The way that the Game Boy stores game data is through a collection of memory banks which developers can choose to put data on one bank or another. Next we have the SRAM, or the static random access memory. This is where the game is going to store your save data. So just to clarify, save data in SRAM and game data in ROM. Now at the very bottom you can see the pinout, and these pins allow the Game Boy to actually interface with this hardware on the chip. Some important parts of the pinout to be aware of is on the left we have power followed by clock. In the middle we have A0 to A15. These are 16 address lines that tell the ROM what particular bytes of data to read. To the right of that we have D0 to D7. These are 8 data lines that allow us to read bytes of data, and these data lines can be used to control which ROM bank we want to load. Next we have a reset, audio in, and ground. So now I'm at a crossroads. I want to mod my Pokemon game, but I don't want to tear apart my Game Boy. So while I was in the process of reading threads and learning how other people tore apart their Game Boys, I stumbled across a modder who has replicated some of the internals of a Game Boy Color and sells it online for somewhere between $30 and $50, a device that's capable of writing and reading Game Boy ROM and Game Boy SRAM. So I decided to pull the trigger and buy this modder's tool, and here's what I ended up with. The tool that I ended up purchasing is called GBxCart RW, and this is version 1.4. It's USB-C enabled, and it duplicates the internals of a Game Boy via connecting to the pin board on a Game Boy Color game. As a result of this, what you can do is you can easily use this modder's software to copy the contents of the ROM and the SRAM, get the game data and the save files. You can copy them onto your PC, but on the other hand, you can also flash them back onto the cartridge, and that's a really useful combination. That means instead of having to toy around with the electronics any further, what I can probably do here is copy this data onto my PC, work with the tools that I'm most familiar with, make some changes to the game and to the game save files, and then write them back to my cartridge, plug that cartridge into my Game Boy, and load up my Game Boy with the newly modded Super Pikachu that's capable of defeating Brock and the Rock Pokemon Gym. The next step for me was to download this software called FlashGBX and use it to try to rip a copy of my Game Boy ROM and save file over USB-C. I ended up switching to Windows because I read online there was greater compatibility, and I found that it took multiple tries in order to get a backup copy of my ROM. Once I finally did get a backup copy of my ROM, I was able to get a backup copy of my save file in just a few seconds. The next steps after this were I downloaded a Game Boy Advance emulator called Visual Boy Advance, and I figured I would check the ROM to make sure it runs in the emulator just to make sure all the data is there, and it did. In addition to that, I figured I would check my save file in the emulator, and it turns out my save file was correct and didn't seem to have any issues based on my memory of where I saved right before the Rock Pokemon Gym. So after using FlashGBX, I was left with two files. I was left with a .gbc file as well as a .sav file, and I figured the first logical steps would be open these up in an editor and try to figure out what they were. You'll notice that I made a copy of the save file at the top, because often when I'm working with something that I'm not familiar with, and in fact this is always a good practice, I wanted to make sure that if I made any edits I didn't just fully corrupt the file without knowing that I did, and then I wouldn't have a backup and I'd have to go back to my hardware. Now here you'll notice that my editor, Visual Studio Code, gave me a warning, this is a binary or something else, and it turns out, well, what did you expect? Of course it's a binary or something else. Next steps for me was to try to potentially open it up in a hex editor, see if there was anything that I could edit in the save file, but even while I was doing that, I knew that it probably wasn't the correct path forwards, because what I really wanted to implement was some complex changes. My vision was to introduce either a fully new Pokemon or an evolution of Pikachu that was much more powerful, and I didn't think I wanted to do that all in a hex editor. Now, I opened this up in HXD just to check it out. I opened up both the .sav file as well as the .gbc file, and for those of you who aren't familiar with this editor, you can see the offsets on the left, and then all of the hex data is on the center, and the decoded version is on the right. So as you highlight this data from left to right, what you're doing is just highlighting across multiple variables, and the data inspector on the right is what I was using to see if anything stood out to me as, oh, maybe this is a great place to start my journey into modding this GBA ROM and save file. The next logical step for me was to try to go online and figure out how to disassemble this back into some assembly code so I could actually read through the operations that go through this ROM and potentially run through the save file in order to figure out what data, what logic I had to edit in order to make my modifications. Luckily for me, I found a user Pret on GitHub who disassembles Pokemon games as a hobby. He just so happened to have disassembled Pokemon Yellow under his repository PokeYellow, and so I figured that I would clone that to my desktop and start looking through it. So that's exactly what I did next. Here we have the fully disassembled version of Pokemon Yellow in Visual Studio Code. This is all assembly code that compiles down to machine code for the Game Boy, and it took me a long time in order to actually dig through all these files. Now, when I'm doing some type of reverse engineering project, the first thing I do if I have access to code is I start searching for things that I'm familiar with. So I did a search for Pikachu initially. I found like almost 2,000 results, and I just started going through those files and trying to figure out what's going on. Right on the screen right here you see Pokédex constants. That's a file I found, and I didn't think it had much value. In fact, I thought I could add a new Pokemon potentially without doing a lot of additions to the Pokédex. Turns out that's completely wrong. The way in which this game was coded, it was coded so that the game mechanics are very tightly bound to the Pokédex. Rather than having two separate data stores or one highly diversified, well-organized data store, essentially everything is kind of intermingled. So if they can draw from the Pokédex to get a name or a description anywhere in the game, rather than drawing from some other source of information, they'll definitely do it. They even use the Pokédex constants for ordering, and I found that out the hard way because my process was make some changes and then build a new ROM based on this data, and then test that ROM, and then make some changes, build a new ROM. Well, it turns out sometimes it's not going to compile if you don't have the Pokemon in another file in the same order of the Pokédex, even if we're not talking about anything slightly related to the Pokédex. We could be talking about, you know, the graphics that the game displays when you're in the middle of a battle. Nope, they have to be in the same order as the Pokédex as well in that Pokédex constants, because it looks at Pokédex constants, it doesn't see, the logic doesn't see, oh, Pokemon 152 is Megachu, Pokemon 151 is Mew. It sees Pokemon 151, 152, and then it says, I'm going to show you the graphics for 151 or 152. Here you can see what I'm doing is I'm creating a Megachu.asm file. There is a base stats file for every single Pokemon. Defines base stats, a couple of rules like what TMs and HMs it can learn. Once you add a new Pokemon base stats file, you have to add a include in the base stats.asm. It's pretty straightforward. I would actually say the best thing you can do if you want to work on modding your own Pokemon game and you're working with this disassembly is look for the Pikachu or the Charizard or any other Pokemon under /Pokemon/base stats, because there's a lot of references to other useful files in there that I found. Now here I'm in evomoves.asm, and although the moves are defined at level 1 inside of the base stats, the moves upon level up are actually defined in evo moves, I found out. And to make things a little bit more complicated, evolutions are actually defined in evo's moves as well. So this moves file defines moves as well as evolution paths. Like you can see the Pikachu EV item Thunderstone 1 Raichu. This is defining how a Pikachu evolves into a Raichu. You could also do EV levels. So you could define cross species evolutions here or new Pokemon evolutions, which is what I chose to do. I added Megachu as a new Pokemon, and I added him as a optional upgrade path, an optional evolution path from Pikachu. Now, in order to compile, now that we've done this, once again, we have to go back to the Pokédex again, and we have to create a new dex entry. This dex entry is going to be for Megachu. You'll see a lot of references here and a lot of data that's not even documented. 1,4 in Pikachu is Pikachu's height, 130 is Pikachu's weight. So, oftentimes, this assembly code is so bare bones in order to save space on the ROM that it's written in very funny styles, very poorly documented. The naming conventions can be odd. Oftentimes you'll see code in here that uses kind of space storing hacks. And as a result of this all, you just can't really rely on the code. You have to just play around, build a new ROM, test the ROM, make some modifications, and keep your own notes as you go. Because this is from back in the day when space was of utmost importance. Here you'll see section 1 pics. This is pics.asm, where battle front and back pics are defined. It's very easy to break the game here, talking about memory, because each of these categories refers to a data bank on the ROM, and if you put too many pics in one category, you'll overload the ROM, and it actually won't be able to write to the Gameboy cartridge, and so you'll have a failure there. That file also expects everything to be in the same order defined in Pokemon Constant, so now you have this issue where you have too many Pokemon in one ROM bank. You actually have to shift all the other Pokemon below it downwards. Now there's only 7 available here for picks, and as a result of that you can only store a maximum of 190 something Pokemon. So you can add a couple extra Pokemon to your ROM, but you can't add an unlimited amount because of the limitations of the Game Boy hardware. Next up, adding custom graphics. Now I expected this to be an easier step, however it actually turned out to be a relatively difficult step. Not because creating the graphics was that difficult, I don't claim to be any type of artist, but creating some basic graphics in Paint.net and other image editors, I can do that. No, because there's so many rules that this Pokemon game has when you're trying to render Pokemon. Now, let's start off the top. Whenever you're in a battle, you have a front and back image for each Pokemon. You see the back image because you're behind your Pokemon, and your opponent's Pokemon, you see the front image of that Pokemon. Okay, so we need 2 images. Now they have very specific dimension requirements. That's not so big, I expected that. But going beyond the dimension requirements, there's also color requirements, and the fact that you can't even include your own colors. So here's what I had to do, and I had to figure this out the hard way by compiling, getting errors, having things render incorrectly. I created 2 images, front and back, for Megachu. Now the front image is a little bit larger. The back image, however, rather than changing the orientation is relative to a horizontal divider on the screen where you see the enemy Pokemon and your Pokemon. Rather than changing the orientation in the code, what they do is simply have an invisible border on the bottom and the right of the image where you can't put any pixels. If you put pixels there, then they will go over the user interface while you're in battle mode. Okay, so from that I had to adjust my back image so that there is space at the bottom and space at the right so that it doesn't overlap with the user interface during the battle scene. Next off, I realized that the images themselves must be grayscale, and the compiler will throw an error if there's more than 4 colors in any given image. So I went over to GIMP and I found out that I could use GIMP's palette tool to convert this to a 4-color image. And by converting it to a 4-color palette, I was able to get past the limitations that I found with the compiler not being able to accept images that had more than 4 colors. Now, there was one more step that I figured out. So I had figured out the dimensions, the invisible borders, and the colors. But given that other Pokemon in the game had color, how was I to go about adding color to my Pokemon if the images I supplied had to be grayscale and could have no more than 4 colors? So no more than 4 shades of gray. Well, it turns out there is an assembly file called palettes, and within that assembly file you can assign conversions to those 4 colors, and that's what I had to do for Megachu, is assign conversions where it would convert each color of gray to a different color at runtime. So as it's rendering it, it takes this gray 4-color image and then adds some color in wherever the grays are, replacing the grays. And by doing that, I was able to finally get a working graphics set for Megachu. After that was all said and done, I went back to my terminal and I typed in make to run the compiler and generate a new .gbc Game Boy game ROM. Now at this point, the only thing left was to take that newly built ROM and flash it onto my Game Boy cartridge using FlashGBX, boot up my Game Boy, and finally defeat the Rock Pokemon Gym with my newly created and never before seen Pokemon, Megachu, the alternate evolution for Pikachu.